All right, welcome to day 5, or actually our third day of review, but this is our 5th topic, which is going to be on side splitter theorem, also some properties of triangles, and then the Pythagorean theorem. So, side splitter theorem time. So remember, the side splitter theorem really is talking about the fact that we're taking a triangle and we're drawing a line that cuts through the triangle that is parallel to the side across from it. And what actually is happening is that we're creating two similar triangles, okay? Our triangle 1, which is the really big triangle, and then triangle 2, the really big, and then the small one formed by the up top by the line cutting through. So what we're going to do to solve a lot of these questions is create proportions using the side lengths. Now there's two main proportions we're going to look for. One of them is the top line cut for their side splitter theorem. So you can see it's QR over the bottom. All right, so top over the bottom here. All right, as the first one. And the second one is actually coming by just comparing the sides in the small triangle, all right, to the sides of the really big triangle going all the way down. All right, so when you're doing this one, and this is R again, you're going to see that this is actually QX. So this is like big triangle over small triangle. All right, and actually I'm going to move that down here because another ratio that you can create here that we haven't is using the two sides from the side splitter theorem, the actually split side and the side on the bottom, which would be xy over rs. So usually when you notice they're giving you these two parallel lines, that's when you're going to start definitely using big triangle over small triangle. All right, now there's a corollary to this, which is where you don't actually need a triangle, but that you can use parallel lines. So if we have 3 parallel lines and we cut through 2 transversals, 2 lines that cut through them, then we can also create a proportion of the top to the bottom. All right, or we can compare, for example, the top to the whole line. And if we did that, that would be like AB over AC is equal to WX over WY. This is another option, or the bottom to the whole thing. So in these cases, and this doesn't usually show up as much as this one will. So we're just going to do some questions involving the side splitter theorem. So key things to look for in the side splitter theorem are going to be if it mentions that the lines are parallel, that's going to be something that you can catch, or if it says anything about the triangles being similar, like this one, where this is drawn in. All right, so starting with the first one, remember always label your figure. We can see that that's already done for us. And then we're going to call the side we're looking for, which is this whole side AC, we can call that X. And once we notice that we're using the whole side length, that tells me that we are going to be comparing the big triangle to the small triangle. Okay, so on this side, we're also going to need the big triangle. And so 9 plus 5 is 14. And now we can go ahead and create a proportion. All right, so big triangle on the left is 14. The small triangle is just the top line here on the left, which is 9. And that is equal to the big on this side, which we know is x, over the small, which is just that top side here, which is 9.2. So what we can do from here is go ahead and cross multiply. So we're going to multiply 9 times x, which we hopefully know by now is just 9x. And then 14 times 9.2, which turns out to be 128.8. Last step is divide by 9, and we get an answer of 14.31 repeating. So 14.31 would be the most appropriate choice. All right. Number 70 right next door. So this one says so it's telling us the triangles are similar. So we can identify the triangle on the top as one of our triangles, and then the entire length of the line here represents the other triangle. All right. So if we're going to make our ratios, we need to make sure that the ratio over here, like the scale factor, is the same on both sides. So for example, when you look at the first one here, okay, AD is 3 and AB, the whole line is 6. You can see this is like a 2-to-1 relationship. This is double. So when we look at the other side, AE being 4 and AC being 12, you can see that this is not the same, okay? And if you make your ratio 6 over 3 equals 12 over 4, you can always check this by cross multiplying. So does 24 equal 36? It does not, so we know that that is out. We're just going to switch colors here. So if AD now instead is 5 and AB is 8, is that the same as AE being 7 and AC being 10? So once again, if we do 5 over 8, this time we're doing small to big. We want to do 7 over 10. And if we cross multiply, once again, we're going to get 50 is supposed to equal 56, which it does not. So we know that choice is out. So what if we try the next one? AD being 3 and AB being 9. You can see this is a 3-to-1. And if we create 5 to 10, we really don't have to do any work here, just to know that this is 2-to-1 and 3-to-1, so that's not going to work. All right, and that means the last one has to be your choice. So if this is 6 to 2, that's a 3-to-1 relationship. Then 5 to 15 is also going to be a 3-to-1 relationship. And so that's going to be our choice. Okay? But when in doubt, make your proportion and then cross multiply. That's 30. 6 times 5 is 30. 2 times 15 is 30. And so we know that it does check. All right. Number 71. Let's go ahead and do this one together here. I already did this once and noticed that my microphone was broken like last time it wasn't working, and then I was able to fix it. So here we go. Now, number 71. In the diagram below, D and E are an AB. Once again, it points out that these lines are parallel, so we know we're doing side splitter. And then we're going to label. So 24, DB is 12, DE is 4. What is the length of AC, which we can call X? Remember, as soon as we are given the two lines that are parallel, that should tip you off that we're going to be using big triangle to small triangle here, okay? So keep that in mind for yourself as we're working. All right, which means we're going to need to know this entire side as the big triangle, which is 36. So big to small, 36 over the small side on the corresponding part is 12. Big X over corresponding 4. Cross multiply, 12 times X is 12X. 36 times 4 is 144. And then divide that out, and we will get 12 as an answer. And because we call it ACX, we're going to be good to go. Please make sure you always double check what the question is before you circle your answer. Okay? A lot of times they'll ask you for something other than what you're trying to find. There may be an X in the question, and then you're looking for an angle measure. And I guarantee you the X is one of the answers, but it may not be the answer to that question. So reread the question before you circle. All right, 79. Once again, we have this labeled. And it says, explain why these are parallel. Now, key thing here. Explain means you have to use words, okay? So you can show some work, but you need to make sure you discuss that work when you're done. So remember that in order for this to be true, we need to know that these two triangles that are being formed here are, remember, similar. Okay, so are the triangles similar is the question. If they are, then we're good to go. And if they're not, then they're not going to go. Since it says they're parallel, they should be. Now, that means we need to use one of our formulas for similarity, one of our theorems. So either side, 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 angle, 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 or side, angle, side. Now, since we don't have all three sides, we know it's not going to be that method. And since we don't know angle measures, that one's out. So we need to check for SAS. So I have to do a proportion to do the sides. Okay, and I have to find one congruent angle that has to be included between the sides. That means if we're talking about these two sides, that would be the angle that's included. Okay? So here, you'll notice that this angle that's up top, right, is the included angle, and it's also shared in the red and blue triangle. That's key. Now we're going to do our proportion. So we have that done. Now we need to do the proportion. So if we do small to big, now the big, remember, is a combination of these two sides. So 8.75 for this side and 10.5 for this side. So small to big, 3.75 over 8.75. And if you flip this upside down, totally fine. You could do big to small if you wanted to. Equals, and then once again, we got to be consistent. So small side, 4.5 over, careful not to put 6 here, it's the whole thing. Okay, how do we check to see if these are proportional? We can just cross multiply. Make sure we get the same thing on both of these. Now, another option you could do is just type 3.75 over 8.75 in your calculator and see if it gives you the same thing as 4.5, I should say, over 10.5. This is also equal to 3 over 7. So this is one way to demonstrate this. The other way, like you said, is to cross multiply and show that you're going to get 39.375 equal to 39.375. And this is a way to show that these are proportional. So we're going to make our statement as to why. So we can say AB is parallel to CD since triangle AEB is, we don't have to write is similar. We can just put down the little squiggly symbol for similarity. Okay, is similar to triangle, remember we said AEB, so we want to say CED to keep the side line, the angles, and the corresponding positions by the SAS squiggly theorem and the side splitter theorem. Okay, now if you didn't remember side splitter theorem, okay, what you could also point out is if the triangles are similar, okay, that means that angle A is going to, we can't say A because remember, there's more than one angle A, so we're going to have to use 3 letters there because there's this angle A and the angle below it. So angle EAB, that's this angle right here, is going to be congruent to angle ECD or angle C. All right. Because the triangles are similar, and this means that AB is parallel to CD because the corresponding angles are congruent. All right. You can see that was written there before. And that is going to finish off our proof. So, options. We say that these are parallel, we say the angles are congruent, and therefore the lines are parallel, or we mention similar and then just side splitter. Those are the options for that explanation. Okay, 74. So in 74, let's see if you can try this one on your own. All right, so pause it, give it a shot. Let's see what you get. All right, so hopefully you went through and noticed we got to do big to small. So this entire side AC is 24, and then we can plug in and do 24 over 15 is equal to 40 over x if we do big to small, and then we can go ahead and cross multiply here. All right, so 24x is going to equal 600, and then divide by 24 to get an answer of choice 3, which is 25. All right, let's take a look at the next page. All right, so quick stuff. Some fun facts, or highlight that one for you guys, about triangles. Number 1, the largest side of a triangle is always across from the largest angle, and the smallest side is always across from the smallest angle. So you can kind of think of it this way. If I have a triangle here, okay, and I want to increase the value of this angle, the length of this angle, so what I can do is stretch this angle out so it increases. Notice that the side length also has to increase here in order for this to stay a triangle. So as this side gets bigger and bigger, we head in this direction, this side length is also going to increase. So as the angle gets bigger, the side length is going to get bigger as well. Okay? So small side across the smallest angle, largest side across the largest angle. Number two, the area of a triangle, remember, is 1/2 base times height. All right, the exterior angle theorem, the EAT here, just remember that the exterior angle theorem says that we have a triangle, all right, and we extend one of the sides out, we're going to end up with this exterior angle, which we'll call angle 1, and this is going to add together to equal the two remote interior angles. Now, it's not the opposite, it's just the exterior angle. That means if we call this angle 2 and 3, this angle is not remote because it's connected to it. These are remote. They're all the way off by themselves. So angle 1 is equal to the sum of angle 2 plus the sum of angle 3, or plus 3. All right? And the last two, remember that the interior angles of a triangle add to 180, and any shape always, okay, the exterior angles add to 360. Any polygon, we should say. All right, we remember the Pythagorean Theorem. Remember, leg squared plus leg squared equals hypotenuse squared. We also came up with a formula. Remember, if we did c squared minus b squared is equal to a squared when we're looking for a segment length. And then we can also remember that if we create an inequality here, if the hypotenuse is bigger than the triangle's obtuse, and if the leg sides are bigger, the square of the legs is bigger, it's going to be acute. All right, so let's take a look. And the other thing we're going to mention that's going to pop up here is an isosceles triangle. So remember, in an isosceles triangle, we have some side lengths. Remember that in order for it to be isosceles, we have to have two congruent sides. These sides, are referred to as the legs. All right. And the other side down here is referred to as the base. These two angles that are equal are referred to as the base angles. Okay. And then the angle that is not congruent up top is the vertex. So remember that the congruent angles, the base angles, are always across from the legs. That's important when we're doing questions with isosceles triangles. All right, let's take a look at number 83. So given triangle ABC, we have everything labeled here. If it's not labeled, make sure you label it for yourself. All right, and it says B is 62, side AC is extended. Which value of x makes this true? Whenever it asks which value of x makes this true, what we want to do is actually just assume that it is. So if this is true, we're going to go ahead and assume, okay? So count it as a fact, and then figure out what x has to be if that fact is true. So if AB and BC are equal, CB are equal, okay, that makes our triangle isosceles, and the two base angles in the corner have to be equal. So if we can figure out the measure of these angles, then we can get x, and we'll be done. Now, we can just call this another variable like y, and we can create our inequality, because remember, they add to 180. So 62 plus y is equal to 180. All right, we'll move that 62 to the other side, and then combine like terms to get 2y. This is going to be 118, and then we'll divide by 2, so that y is equal to 59. Now be careful, 59 is a choice. It's not the correct choice, though, because we're looking for x. So remember that this angle would have to be 180 minus 59, and that would be 121. And that should be the correct choice. Okay? Number 84. We have our extended line out here. So remember, this is the exterior angle theorem. All right? These questions are easy. We should want to eat them up and get all the points. Now, what that means is this exterior angle is equal to the sum of these two angles. Okay? So we can make an equation. 180 minus 3x, it's hard to read, remember those angles are right here, is equal to 6x minus 40 plus x plus 20. So let's combine like terms. 180 minus 3x. This is going to be 7x, and then minus 20. We're going to move the 3x over to keep that positive. So that's going to give us 10x. And then we can move that 20 back to the other side, so we get the x's by itself. And we get 10x is equal to 200. So that means that 20 should be the value of x. Now, careful. It doesn't ask you what x is. And 20 is one of the answers, but it's not the correct answer. We want the measure of angle BAC. BAC is this angle right there, okay? In order to get that, you have a couple options. We can figure out the measure of this angle, 180 minus 3 times 20. So 180 minus 60, right? Tells me that this angle is going to be 120 degrees. That means the angle we're looking for has to be 60. And that is choice 3. So always reread the question before you circle your answer. All right, 2 more. Number 85. So once again, we got a diagram below. We have the angles labeled already for 70 and 28. And the important thing here is it says these two sides are congruent. Now be careful. Don't mark down these two because that's not the two we're looking at. HJ, that's this bottom side, and JK. All right, now our job is to determine whether this triangle is isosceles. So GHK is actually this triangle right here. So we want to know are there two angles in this triangle that have the same measure? So we just got to figure out all the angle measures and compare them. Now, key thing, this triangle is isosceles. And since these two sides are equal, those are the legs, the base angles are always going to be across from those sides. And that's going to be these two. Okay? So we can go ahead and treat these as both x and solve. Now we can also just do 180 minus 70 divided by 2. That'll also work. Okay? So this is 110 divided by 2, which means that both of these angles are both 55 degrees. Okay, option number 1. We can use the exterior angle theorem to figure out the measure of this angle because the sum of these two is the angle outside. Or if this is 55, that means the angle next to it has to be equal. So let's see if you can finish this one up. All right, and then we'll compare. Let's go ahead and pause it here. All right, so hopefully you figured out the answer was no. Remember, if this is 55, then this angle is 180 minus that, which makes this 125. And then if you do use the exterior angle theorem, 55 minus 28 is actually 27, which is the measure of this third angle, or you added these together to get 153 and take it away from 180 to get 27, and then we can say no. Now to get full credit, you had to say no, okay? Triangle GHK is not isosceles since there are no congruent angles. And that would be enough. It would be enough to say no and show this work, by the way. If we have to explain it, that's how we would want to do it. All right, last question here. So, which segment has the shortest length? Now, that means we are looking for the smallest angle. Now, you got to be careful here, okay? Because it looks like this angle is going to be the smallest, but here's the problem, all right? This angle is the smallest angle we'll get, but that would mean that this side across from it, because remember the smallest side is across from the smallest angle, would be the smallest. But remember, that is actually the largest side in this triangle. So how can it be the smallest if it's bigger than these two? The reason we know it's bigger is because 94 is obtuse. So this side would have to be the biggest side in this triangle. So not only does it have to be the smallest side, it also has to be the smallest side in the smallest triangle, okay? So keep that in mind, all right? So in order to do that, we're going to have to figure out some other angle measures. So we can go ahead and add these two angles together, which is going to give us 68. So 180 minus 68 is going to equal 112. So that'll be the measure of the angle up here at NYA. And then we can also add 94 and 46 together to get 140. And so this angle would be 40 degrees. Now, since this angle is now our smallest angle in the smallest triangle, that means that VA would have to be our answer instead. This is the only question they've asked on lengths of the sides of the triangles based on the angles. so this is probably not going to come up, but I just wanted to make sure we talked about it today. So what I'd like you to do from homework is, if you didn't get a chance to finish up yesterday's worksheet because the volume was broken on it, please make sure you check the folder from yesterday and watch that video for homework and finish that up. Okay, so tomorrow I'll be looking to see that both of these worksheets are completed. All right, there's no problems to do on your own today. Just make sure that these 2 worksheets are done, and then we will work on some questions in class together based off of all the stuff we learned these last 2 days. Now, key thing, pro tip, in YouTube, if you click on the little settings wheel in the bottom corner, you can change the playback speed. So if you want to change it to like 1.5, it'll play at a little quicker speed for you, just in case you wanted to get through the video a little bit quicker. Just make sure it makes sense and that you know what's going on and you're not just watching it as double time just because you want to hear Mr. Z sound funny. So, all right, that is it for tonight. Hope you guys enjoy the videos and they're helping. Just make sure that when normally we're doing these for homework and then we're working on the problems together. So have a great rest of your day, and we'll see you tomorrow.